Okay, and we are back with our third guest. Wow, we are spoiled for choice today with all of the exciting content we have. Joining us to talk a little bit about Amazon Redshift's new data sharing feature is Neeraja Rentachintala, Principal Product Manager over on the Redshift team. Neeraja, thank you for joining us.
Thank you.
Wonderful. Well, we're here to talk about data sharing. Sorry, it's so much Redshift content today, but I know for anyone in the audience who's tuning in and at least has stuck around for this long, I think they're probably in the right place, and you are certainly the right person to have to talk about this exciting feature. So tell us a little bit more about the data sharing space. We've seen so much about what data warehousing is valuable for, and flexibility in the super data type, and how Aqua makes all of our queries more performant. But sharing data seems like a problem we haven't broached at all today. Why don't you tell us a little bit about why that's been challenging historically?
Yeah. Yeah, so in data sharing, I would say is one of the exciting features. We have announced this at reInvent last year, and it recently became GA in March timeframe. So many of our customers are very, very excited about this recent launch. So in terms of the problem that we are trying to tackle, right? So if we have multiple Redshift clusters prior to data sharing, and you're trying to share the data between these clusters, right? So these could be different business groups that are trying to share the data, or you're trying to share data from an ETL, like where you bring the data in and process it with a number of business intelligence clusters. So in these scenarios, you have to kind of set up pipelines between these clusters. So you have to kind of write the ETL code and spin up these pipelines. So essentially, the big kind of issue is the complexity, right? So building and managing the pipelines can become complicated, and especially if you're trying to share the data with many, many consumers, these pipelines can become very fragile. So it's a maintenance kind of complexity. The second aspect is it's also a security and governance concern, because if you don't have a direct way to share the data today, basically prior to data sharing, you need to unload the data from Redshift and copy it to the other cluster. And this can impose security concerns because you have no control on where the data is going and who is accessing the data. So that I would say is a complexity from the producer of the data. But from a consumer perspective, it's really the data delays. So these pipelines may not be running throughout the day. So you probably are running it like 2 times a day. That means you are working with stale data for most of the time. So that's, I would say, like the stale data is a big concern. And another aspect is, again, if you have many, many consumers, they might be looking at inconsistent use of the data. So with data sharing, essentially, we're trying to simplify the whole data management and the data movement between Redshift clusters.
Yeah, that sounds like a pretty interesting and difficult set of problems that you just highlighted. How does Redshift data sharing solve them?
Yeah, so what customers actually, maybe just to expand on the previous point. So if you don't want to deal with, as a customer, if you don't want to deal with this data movement kind of an issue, you typically put in a lot of your use cases in a single cluster, right? So you might want to, because you don't want to deal with the data management. So try to put in a single cluster, but that is not a solution for all the situations, right? You might have a very decentralized environment where you may not be able to bring in all use cases into a single cluster, or you're trying to share data with your partner. So a single cluster is not an option. So I think there are alternatives today which work for certain customers, but that does not work in a decentralized kind of environments. So what data sharing tries to do is essentially provide a secure and easy way to share live data between Redshift clusters. So there is no data movement, no data copies involved. One Redshift cluster essentially can access live data from another Redshift cluster.
I feel like
how does that, so one of the, sorry, quick follow-up. One of the things, the problems you mentioned was, if let's say we have 2 departments and they each have their own Redshift cluster, the trade-off, as I understand it, when you merge these into one cluster, is that now you've eroded some of the protections of the isolation of having two separate clusters. Maybe you have one cluster and that cluster contains data that you've scoped down to the permissions of user group A, whereas the second cluster you've scoped down to the permissions of user group B. But now when you say that with Redshift data sharing that hypothetically B has access to the live data of A, how does that isolation and authorization and data protection, how are those policies still enforced?
Yeah, so I would say, I mean, the data side always can be controlled with security permissions, right? Even if you place multiple business groups in the same cluster, you can control the database permissions in a way that the relevant people are looking at relevant data. So data side, we have isolation because you can organize the data and set up permissions. The issue really comes on the compute isolation side. So if many workloads are trying to operate in the same cluster, Redshift has pretty sophisticated workload management, but if you are trying to do like complete isolation and even chargeability, right, based on the compute resources you want to offer chargeability, that compute isolation is not possible in a single cluster. So they would be competing and for certain resources. So if you want a full workload isolation, that is when the multi-cluster kind of deployment comes into the mix. The data isolation can be handled in a single cluster. You can also obviously handle it if it is a separate cluster.
Yeah. When talking things, it feels like there really is a lot of challenges to sharing of data. Who would have guessed, right? But what I'm hearing is single cluster has obvious concerns around sharing and distributing time for that cluster and data governance concerns. Another scenario where you're making copies elsewhere has syncing issues where you're not operating on a truly live set. There's delays to that. And then for just functionality around business use cases where you're sharing data, maybe in like a marketplace scenario where you have access to data in your warehouse and you want to share that for someone else to perform their compute on, the functionality, previous Redshift data sharing wasn't entirely available. And so it's both really a technical challenge, it sounds like, as well as sort of a use case challenge, all rolled up into one feature.
Right. And it's also, I mean, I wouldn't say like it's practically impossible to solve some of these problems. And I think that the main point is it's just the complexity, right? We have many customers who have tens or even hundreds of Redshift clusters, but they kind of build and manage the pipeline. So there is complexity involved. So data sharing certainly simplifies some of this data management complexity. And as part of it, it also opens up use cases. So for example, like the data sharing supports sharing across clusters that are in the same AWS account, but they can also be in different AWS accounts. So suddenly you can open up live data to your own customers, partners, your entire business ecosystem. So there are basically the marketplace type of use case that you mentioned. So it's a lot more easy, right, to explore kind of these new business opportunities.
Yeah, and when we're talking about data sharing, I think the one obvious question starts to become, what is the granularity for control? Are we talking entire tables? Are we talking limit at schema, row level sort of entities? Like, what are the controls for how one could determine as a data provider what they are sharing?
So there is a lot of flexibility, right? So as a data provider, you can choose the granularity at which you want to share the data. So Redshift is a database, so it has the constructs of database, schemas, tables, views. So data sharing can be done at any granularity. So if you want to share a single table, you can do that. If you want to share an entire schema, you can do that. We allow sharing views, materialized views, UDFs, like user-defined functions. So there is complete control on how you want to share the data and what exact objects you want to share the data. And then the important point I think is worth mentioning is the producer also has control on the retains the control on the data. So at any point they say, okay, I wanted to share this particular table only for a couple of days for your analysis, but after that I want to revoke permissions. I can do that and immediately the data disappears from the consumer, like instantaneously. So the producer retains control on the data sets.
Yeah, awesome. Those control dials are pretty important. You mentioned earlier that you seem to have said that there's 3 key benefits. There's this kind of workload isolation, chargeability, and different collaboration, enabling different collaboration models between organizations. Is that roughly right?
Yeah. So I think the workload isolation, chargeability, this is a very, very common use case, right? So even within a business group, I might have like a dashboarding workload and a data science workload, or some ad hoc users coming in and doing queries. So providing isolation so that each of these workloads can be sized according to their performance requirements is a critical need. So that's kind of the workload isolation aspect. And chargeability, if you're trying to offer data as a service, if you could be within the organization, it could be external to the organization as a service, and you want to offer chargeability. The chargeability is kind of implied because this is a multi-cluster deployment, so you can obviously charge for the compute resources that a given tenant is using. The other use case is the cross-group collaboration. And another one actually worth mentioning is just sharing between the development, test, production systems without having to take like a full snapshot and restore is another common use case as well.
Can we dive a little bit deeper into chargeability? I'm not quite sure I understand that. Maybe you can provide some more examples.
Yeah, so chargeability is so we have many customers that use Redshift almost like a OEM, right? So they embed Redshift to power offering the data and analytics as a service to their own consumers, their own customers as a web application or data feeds. So they're trying to offer data as a service. So in those situations, they might have hundreds or even thousands of consumers that are coming in and accessing these data sets. So when you're powering this SaaS kind of environment, you might have big customers, right? That might be doing a lot of computations, a lot of work, and you might have probably like a smaller scale consumers who would just come in and look at the dashboard once in a day. So there are different types of compute requirements. So the requirement really is I want to charge my consumer based on the compute that they have used. So if if I'm allocating like a full cluster that is 24/7 running for them, I want to charge them, offer chargeback to that tenant. Whereas this other small consumer that is just accessing the data for 1 hour in a day, then I want to charge them only for 1 hour of compute resources. So with data sharing, you can basically set up Redshift clusters for each of these consumers according to their own performance and availability requirements, and then charge them. So I think chargeability is kind of an inherent architecture benefit that you would get with data sharing.
I see. That makes sense. Thank you.
Yeah, and one thing, if I understand this correctly, is that with the data sharing, essentially you have, as the provider, the optionality to say, hey, external individuals can perform that processing on the provider's Redshift data cluster, or the Redshift data, the provider could simply be giving access to the data with no access to the compute of their cluster, at which point they're basically charging folks for access to that data. It really gives them the flexibility in my mind where then the consumers basically really get a secure pointer and a tunnel into that data, but then you don't have to worry about performing that compute on your own system. It really feels like this gives the breadth of options for someone that owns data and wants to be able to, build some sort of business around that. I know we've given this marketplace example, but even just to other teams at a company, right? You don't want to duplicate this data and you want a central repository for it. This seems to cross account or even within one account, give them that flexibility for sharing it.
Yeah, and then it also opens up, it makes things a lot more agile, right? So if a new ad hoc business reporting request comes in and a marketing person comes and says, I need to do this analysis, right, for some launching some marketing campaign, then as a data warehousing team or as data warehouse administrator, all you need to say is, okay, go and spin up your cluster. I'll just share this data. So things are a lot more agile because it's just compute resources that you need to spin up. And the tough part, which is the data, doesn't need to move around. That is where the time is typically spent. And I think technically it's worth highlighting that the data sharing, just from an architecture perspective, it is the consumer clusters, Redshift clusters are accessing the data via the Redshift managed storage, which is part of the RA3 node types of Redshift. So what that means is when the consumer queries come in, consumer cluster queries come in, they are not hitting the producer cluster compute, right? So it's not impacting anything that is happening on the producer. The data access is happening via the managed storage layer. So that is where the workload isolation, the consumer is doing their work, producer is doing their work, but they're accessing the common data becomes interesting.
Yeah, all really good points. I can't wait to see this in action. Do we have a demo ready?
Yeah, so Rajesh from our team will be doing the demo. Rajesh, you want to take over?
Yes, sure, Neeraja. I can take over the demo. Thank you. And I'm going to share my screen.
Yeah, whenever you're ready. And while Rajesh is getting that set up, I actually had just one more question because I think it was really interesting. Neeraja, when we're sharing this data, security controls become pretty important, I'd venture, right? Both, wanting to know who you're giving access to, but then also on the consumption side, you want to make sure that there's approval steps here for accessing data from externally. Could you just talk to some of those while Rajesh is getting his screen share?
Yeah, so I would say the two biggest design points I would say for data sharing is one is performance, because that's the basics. It has to perform well. The second aspect is most important aspect I would say is security, right? So because with data sharing, data could be going outside your business group and possibly outside your organization. Proper security controls are super critical. So there are many things in data sharing that to allow that secure interaction. So for example, on the producer side, not everybody can create data shares. So there are strict privileges on who can create data shares. Typically it is database super users or database owners who can do this. And the second aspect is the granularity we talked about, right? So you can give the right access to the data. You don't have to open up everything. And at any point, the producer is retaining control on the data, so they can revoke permissions. And for cross-account use cases, so when you're trying to share data across clusters that are in different AWS accounts, there is an extra handshake where after the data sharing is done at a SQL level, the producer account administrator needs to authorize the sharing. And similarly, the consumer account administrator needs to accept the share. So there is a handshake that need to happen using the IAM permissions in order to kind of authorize these sharing policies. And similarly, on the consumer side, the consumer cluster administrators, consumer account administrators have complete control on who should get access to the data. And they can even further subset the data by creating views, Redshift views. And I think the final point is there is full auditing both on producer and consumer side. So there is visibility into who is using it, to what extent it is using, what extent they are using it. So there is visibility and control from the usage perspective as well.
Yeah, no problem. Rajesh, could you give us a quick description of what we're seeing here?
Sure. Yeah, I'll start with the demo. So my name is Rajesh Francis. I'm also part of the solutions architect team at AWS. And you heard from Neeraja about Redshift data sharing. And now I'm going to demonstrate how you can set up and use Redshift data sharing both within and across accounts. So as Neeraja pointed out, there are many use cases for data sharing, workload isolation, data or analytics as a service with ability to charge back to subscribers. That's really what I'm going to demonstrate here. And the other use cases being cross-group collaboration or sharing data across your dev, QA, and prod environments to enable agile development and also improve quality of data for your testing. So for this demo, I will cover analytics as a use case, as a service use case, and demonstrate how a healthcare analytics provider that has a producer or a provider cluster that stores the data can use data sharing to share data with the subscribers. So the example we will use is hospital data, which is COVID inpatient occupancy data. And we will use two subscribing states, Virginia and North Carolina, as subscribing states and demonstrate how they can access live data from the subscribers. So what you're seeing here is the producer cluster for the provider. And we will connect to the cluster first. Or I'm going to use SQL Workbench, which is SQL Analyst service that is in preview, private preview. And once we connect, I've already connected to the cluster. This is the provider cluster. And I've created two tables, one COVID inpatient bed occupancy table and a subscribers table. So the subscribers table will have the data for all the subscribers. And here I'm going to use a multi-tenant architecture. What that means is data for all the subscribers are going to be stored in one single table. And we will use a tenant ID or a namespace to restrict access to various subscribers. So here I have two subscribers, Virginia and North Carolina. And I also have the data set for COVID inpatient bed occupancy date by state. And as you can see, I have data for all the states. So the first step in sharing that data is identifying what data needs to be shared. So in this case, I need to share the COVID inpatient bed occupancy data. But since I have all of the data set in a single table, I'm going to use a view to restrict access to the subscribers based on the namespace, based on the cluster that they're coming in through. So this view has all the details of the hospital data, inpatient bed occupancy. In addition, we're also joining this with the subscriber table. And we will use a variable, current namespace. This is a system variable that is going to come in and be populated with the namespace of the subscribing cluster. And that is how we're going to restrict the data. So now that I've created the view and I've identified this is the view that I'm going to share with my subscribers, I can go ahead and create a data share. So this is the create data share command, create healthcare data share. And I can add objects to that data share, alter data share and add schema because this table for hospital data is in the schema called hospital data, as you can see here. And I will also add the view because this is the only object I want to share. Once that is done, I can share this data with subscribing cluster within the same account. As we talked about, the data can be shared within the same account or across accounts. So the first I'm going to demonstrate how you can share this data set within the same account. So I'm sharing it from this cluster to another cluster identified by this namespace. So let's go ahead and connect to that cluster. So as you can see here, I have the producer and the consumer cluster. Now I will connect to the subscriber in the same account and see how we can view that data. So I've connected to the subscriber cluster within the same account.
So Rajesh, what we're seeing here is essentially, again, you said the subscriber's account. This is a Redshift cluster that they manage, or I don't remember if they were in the same account here. I think they are. So this is a second Redshift cluster where what we're seeing here is an example of SQL queries that they are going to try to execute against data that is now not in their own cluster, but shared from the provider cluster, and that's provided through that pointer mechanism that you've called like a namespace, essentially, right?
Yes. Yeah, absolutely. So now that I've logged into the subscriber cluster within the same account, it's just a two-step process to start querying that data. First, I'm creating a database, which is just a reference to that data share that I just shared of the producer namespace, which I've already done. And now I can query this data set. And because I've shared it with this account, and this account can only see North Carolina, and you're seeing only North Carolina data here, even if I sort it. Okay. And you can do any type of analysis on this data set. So that's data sharing within an account. So next, let's see how data sharing can work across accounts. It works very much similar. Yeah, go ahead.
I have a curious question, if you can bounce back for just a second. So I know this whole like compute can be done on the provider's cluster, or it can be done on the subscriber's cluster. In this scenario that we saw here, I see that because you had entered, you've entered your consumer cluster and you're executing SQL queries, does this consume compute from the data provider, or does this consume compute from the subscriber here?
Yeah, this is totally consumed by the subscriber cluster. There is no compute that's used from the provider. With Redshift data sharing, we have data stored in Redshift managed storage. And when the provider, when the subscriber accesses this data, this shared data set, it's going to the Redshift managed storage at the S3 layer and not hitting the compute of the provider at all.
And that makes a lot of sense. I think an additional benefit of that is, let's say, you have this data set and you're vending that to a lot of folks. I know you're about to get into the cross-account scenario, but it would be kind of rough if you were providing this data and then you had to manage and right-size your compute. But in this sort of model, you can make your data available, and then all of the consumers are in their own accounts or in their own clusters having to manage their compute utilization without having to push that requirement onto the provider.
Yeah, that's right. From the consumer side, the consumer can determine how many users get access to this data set, and can also restrict access based on the database objects that are there in the data share. And remember, the consumer is also another Redshift cluster. So that in turn, the consumer cluster can in turn share data with the provider or other consumers. Share, by that I mean they can share their local data.
Awesome. Sorry, I know I interrupted. Let's get into the cross-account scenario, because I think this one is really, really interesting. There's a lot of, we talked about chargeability and all the benefits there. I think this is really exciting.
Yeah. So let's move on to how we can do cross-account sharing. This works very much similar to single account sharing, but there are a couple of steps involved, because the data could go across the organization. For additional security reasons, we have added some checks and balances as part of this sharing. So we will use the same object for demonstrating cross-account data sharing. Now that I have the view created, as you've seen, I'm going to grant usage on that data share. So the view is part of this data share. I can grant access to a specific account. This account could correspond to one of my subscribers. This is North Carolina. And this account is another state that is subscribing to the data set, which is Virginia. So I've granted usage on this data share to these accounts. Now, the additional step I talked about for security reasons or additional approval reasons is this step. So now that I've granted usage on that data share, this data share will show up in the list of data shares in the console, and a manager or approver can come in and authorize this data share. So in this case, I've already authorized, so you're seeing it authorized. But the authorizer can also choose to remove authorization in this case. So now that it's authorized, I will go and demonstrate how we can access from the subscriber account. So to demonstrate that, I have to log into another account. Here, I've already logged into this account. So note that these are two different accounts. This is starting with 9437. This is 7116. And this would correspond to North Carolina. So on the subscriber side, I can list and see what data shares I have available. So this shows that healthcare is already shared. I can also look at the individual objects that are shared with me. As you can see, there's only one view that is shared. This is the schema, but then the list of objects are just one. Then similar to the single account, we need to create a database. It's just a reference to that data share, HealthDB data share of this is the producer account or the provider account and the cluster name. So need to execute that. Once that is done, you can just go ahead and query that data. So I'm going to query this data set. And this is available for the subscriber. So as you can see here, this data is already restricted to just North Carolina. And we'll also demonstrate that the data is live querying by looking at the existing data set and doing some inserts into the COVID inpatient bed occupancy table. As new data comes in, the subscriber will be able to see that data set. Now I have the last collection date for the occupancy is May 13th, and the total records I have is 38 records for North Carolina, right? So let's go back to the provider cluster. I'm going to switch back to the provider now. And let's insert a few records simulating that new patients are coming in. So I'm going to add 14 and 15. And now when the subscriber queries the data set, let's go back to the subscriber. The two new records should be visible right here. So 14 and 15 is visible, and the total count is also increased to 40 from 38. So data sharing is live. There is no data movement from provider to subscriber, and that is where this feature becomes really powerful.
Rajesh,
so since provider, yeah, go ahead.
I want to jump in just to make sure that I have a grasp on this, because this is really exciting to me, because if I'm listening back to what Neeraja said before, and to get this functionality previously, customers or providers would have to build a bunch of ETL infrastructure to pipe the data out to a secondary source. And then there's a lot of concerns of whether that's, if it's not a true change stream, you're always operating on some, given frequency of when that data is updated and sort of batch synced. And you don't know exactly how that's lining up. And really what we saw here was this is really a real-time link that as soon as it's changed in the source database with no additional infrastructure, when you query directly against that data set, it is automatically live at the point of query, because you're copying from that golden source. Is that what you just showed us? Because I want to make sure that everyone at home has that as the takeaway, because it seems very simple, but sometimes you forget what that takes us away from.
Yes, yeah, absolutely. You hit it right there with the ETL simplification, right? There is no ETL process. There is no data movement. Any ETL process would mean including additional jobs, additional operational maintenance requirement that adds on to it. So that's all taken out with live data sharing. And in addition, when you're transferring costs, you're also transferring data, you're incurring additional costs. You're replicating the data, and you have to manage both the data set, make sure that the data is in sync. All of that complexity is gone, where the data is centralized and the same data set is shared across multiple clusters. And it's really one source of truth that is shared across multiple clusters.
Awesome. Yeah, I think that makes it really clear how and why you would use this.
Yeah. Okay, so just one more step to demonstrate. The provider owns the data set. So once the data is shared to the consumer, and if the subscriber wants to terminate the subscription, how do you revoke access, right? That's quite simple. Let's go back to the provider cluster, and you can revoke using the revoke usage on data share on the data share from the specific account, and that's all that's required. Before I demonstrate that, there's also the additional capability about audit. The provider can also audit usage on the consumer, so on the data set that it owns. There are a couple of views that I'm going to show you. This shows SPL data share changelog, shows what has been added to that data share. For example, here we have added an object to the data share. We have removed an object. There are a few changes that have happened to that data share. So that is tracked, and that's available for the provider. And there's another view, data share usage producer. So this gives the capability to audit what objects are being used. So for example, here, this view, COVID inpatient bed occupancy, was queried by this account on such and such a date. So that information is available as well for the provider to analyze how the data is being used.
Yeah, the audit log scenario I think is really valuable, right? Just understanding like, hey, I've shared this maybe with another organization or another account in my company. Maybe you want to, without having to ask them, you'd be able to come into the audit log here and see, oh, well, that account number from that team's service has successfully been able to query some of the data, and you sort of know no news is good news from them. Or alternatively, maybe you're trying to just get an understanding of how your customers in a marketplace scenario are making use of the data. Being able to see some aggregate metrics like that are probably pretty valuable.
Yep. Yes, absolutely. And you can also analyze which of those subscribers are frequently using your data set, to maybe provide additional incentives or chargeback capability. So there's multiple things you can do with that statistics. So finally, we'll see how the provider can revoke access. So I'm going to revoke access to the state of North Carolina. Now, when the subscriber comes back and tries to access the data set, since I've revoked it, the subscriber does not have access anymore. So the provider has the ability not only to share the data, but the provider can share live data, do audit on how the data is being accessed, or how frequently the data is being accessed, and also revoke the data share at any point in time. So that brings me to the end of the demo, and I'll move on to the next steps here.
Yeah, so I'm kind of repeating what I see you about to share there on the screen, but if this sounds at all interesting to you, either as a subscriber or someone that wants to provide data to other folks, again, this is generally available today for sharing within an AWS account, with a public preview if you want to participate in cross-account sharing. Could you talk a little bit about the public preview process? Like, let's say that describes me, right? How can I get into the public preview?
Yeah. Sure. Yeah. So Redshift data sharing within an account is already available. For cross account, we just announced public preview. all you need to do is spin up a cluster in preview mode in the maintenance track, preview 2020. There is also documentation available. And once you spin up a cluster with preview 2020, then that's going to be available and you can experiment with cross-account data sharing. And if you need any additional information, our documentation is quite extensive. Feel free to go into the documentation here. And we also have additional blogs, both for single, straightforward data sharing, single tenant architecture, as well as multi-tenant architecture for analytics as a service use case as well. And we have other YouTube videos. You can go and look at those demos. And for any other questions, feel free to reach out to this email, redshiftdatasharing@amazon.com. And we'll be glad to help out and reach out to you to help set up data sharing for you.
This has been great. I actually saw something that I'm going to ask you to confirm really quickly. I see in Twitch chat, someone mentioned that data sharing is now possible even while a producer cluster is paused. That sounds almost like an oxymoron, but it also sounds really valuable, right? The ability to sort of pause the compute that you may have on your producer cluster while still sharing this data. Is that true? Can I do that?
Mm-hmm. Yes, absolutely. So the producer cluster can be paused, and the subscriber can still access that data set live. And this gives you the capability. This gives you the capability to optimize your costs. So your ETL clusters, the first use case where you're separating your ETL versus BI workloads, your ETL cluster need not be available all the time. So it can be available during the nightly batch load, and then that can be paused. And you can use the same compute that you save here to enable or increase your compute capacity for your subscribers. So that is indeed available.
Wonderful. Well, this, again, a simple interface for sharing and consuming this data. But, when I look at what it would have taken previously with all of the ETL, with all of the thorny side effects of that, I can't imagine a different way that I would want to interact with or share my data or consume it. So, Rajesh, thank you so much. This was a super interesting demo. And I think a lot of folks that are running their Redshift clusters right now or trying to manage delegating that to other teams of their company are really going to be breathing a sigh of relief if they're seeing this.
Sure. Thank you.
Great. Well, I think
thanks for joining, everyone.
Yeah, folks in chat are really excited about this as well. And I just want to say, again, thank you, Rajesh, for joining us and demoing the data sharing feature here for Amazon Redshift.